implementation, and measurement and verification of energy savings. His firm provides turnkey design-build energy retrofit services for multifamily buildings. Welcome, Derrick.
Thanks very much. If you could bring up the first slide. Thank you.
I'm hearing a buzzing sound. I'm not sure if it's somebody's sound.
Is that still there?
It is.
Rick, do you want to try without your headphones? I think it might be just extra feedback from them.
How's the sound now?
Nope, it's about the same.
Okay, I guess we'll just have to live with it because I'm not sure if it's a machine noise. So good morning, everyone. Thanks very much. As Peter mentioned, we've been in business for 30 years. We have done hundreds of energy audits, and we provide engineering, project management for retrofits, and as well as that, we also provide energy retrofits under design build for efficiency capitals, energy performance, ESPA, energy savings performance agreements, and we'll, as well as measurement and verification of the savings, which Matt had mentioned earlier is key to being able to validate the savings. So we have projects which started back in 2014, but the verification was 2014. The actual construction was before that. And each of these projects that you can see here have been in place, and the measurement and verification has been ongoing on a quarterly and annual basis, and all these targets have been achieved. The project that we did for Wood Green Housing was almost $3 million, and under our design build, this was done starting in the middle of the pandemic, and we managed to complete the whole project within 8 months. And Mariga will be speaking to this project a little bit later. So the idea of an energy audit is to understand what energy is being used in the building, how you can use it more efficiently, what measures can we do, and most importantly, what building renewal measures can we affect. We're all looking for reducing energy, we're reducing greenhouse gases, and how do we go about this? So we see this really as a roadmap as to how we're going to proceed within our programs. There are 3 types of energy audits defined by SHRI, which is the American Society for Heating, Refrigeration, and Air Conditioning Engineers. It's a big organization in the States and throughout the world. And they've defined them. The first is a walkthrough audit, which simply is going through a building very quickly, collecting some basic data, looking at the utility bills, and saying, yes, looks like we can save money by replacing the spoiler, or you have some lighting opportunities in the garage, etc. And it's very kind of ballpark. It's not measure by measure. The next is an SHRI level 2, which is a much more detailed survey. We take utility bills, go through an analysis using variables like weather, so it's weather adjusted, could be occupancy adjusted, production adjusted, and we break down the energy use within the building by each of the elements, and do an analysis, and it's a detailed savings calculation. I'll show you some examples of that a little bit later, showing the savings, the costs, and the return on investment. When we step into the energy savings performance agreement or the guaranteed savings, we need an investment grade energy. So it's everything that happens in level 2, plus we also go and do some additional measures. We measure how much air is coming out of a rooftop unit, the makeup air unit, the power being drawn by pumps, motors, etc., the critical equipment. And then we go back to the calculations and we do much more detailed modeling. We go to contractors, we get contractor pricing so that we can guarantee not only the savings, but the pricing as well. So the process involves, number one, if we can get incentives, and we can right now through Enbridge, for social housing, $8,000, up to $8,000, for other buildings up to $4,000 through Enbridge. Collect all the data, we get utility bills, building condition audits, and then we input all of this to develop the baselines, and we benchmark the buildings against each other. And through our site visit, we break down, as I've mentioned earlier, down into the lighting, the heating. Now these are individual, this is not a cookie cutter. Every building we would produce one of these end use breakdowns, because we use this, we want to say, okay, where is the lighting and where is the heating? So for example, heating is 47%, so we know we have that much to play with in energy efficiency. We can't save 100%, because we only have 47% of the energy being used. So we list the potential measures, and we do a report with the financial analysis giving us paybacks or return on investment. The critical thing here is the weather-corrected baselines or any other variable, because this is what we use going forward. This is what we would measure against. The baseline is this black line, which is generated by the computer, and it's really just a simple regression formula based on occupancy or weather or production. And these bars are the actual. And you can see in this case, it's a pretty good fit from the baseline. And this is what we would be measuring going forward. We would input the weather data, and we'd be able to see the savings. And again, I'll show you an example. We really need to know where we are before we can measure how we're going forward and what are we saving. A lot of programs went in, very early programs for lighting, compact fluorescents back in the 90s. We just throw them in and nobody ever measured. So we never really got some good data. Then we go to the tools that we use. So, I mentioned that we use the regression tools for develop the baseline. RedScreen has a good service, has a good software. We use metrics as well. We've developed our own data collection software on iPads, so we go through the building, pick up make, model, serial number of every piece of major equipment, plus lighting, toilets, whatever else we want to model through eQuest, and RedScreen again for clean energy management. And one of the keys to being able to guarantee energy savings and to react in real time is to be able to put in real-time energy management, gas, water, and electricity. We can tell minute by minute how much energy or water is being used in a particular building, which is key when we find out that we're not hitting the target or if we're not close enough. Then we have infrared scans. We have fancy ones, which are done through using drones. This is actually an example here. The drone will get right up, so you'll see the building at the building level. And I'll show you in the next slide, if you can just remember here, you can see, this is the building where the heating, the window wall obviously is where the heating can escape. But on the slab here, it's nicely insulated and it's black, and the same on this the column section. When we go to the next slide, you'll see this is another one that we have taken. This is taken with our FLIR camera. And you can see here, the slab is red, and I'll go back up again. So you can see there's the slab is black and the slab is red, which tells us right away that there's very poor insulation of the slab. And the heating is coming through that slab right through the outside. This is the picture of copper. And again, just staying with the building envelope, we want to make sure that there's air sealing, that we compartmentalize. We don't want to use the stairwells or the fire hose cabinets as a chimney going up. You know, air of chimney effect in buildings. As you come in the front door, the air gets sucked in, and just the elevator shaft or the fire hose cabinet shaft will act as a chimney, and the air goes up at the top of the building. So you seal the top of the building. We want to look at some of the long-term measures, window replacement, eaves, which is the exterior insulation, and then roofing. If you're going to be doing roofing, make sure it's R20. So this is your opportunity. It's roofing is not done often, and you want to make sure. So energy efficiency measures, you know, as Ian had mentioned earlier, you know, heat pumps is one way to go. The advantage of heat pumps is that we can now take, not only provide heating to buildings, but we can also provide cooling. So with climate change, we need to be able to provide some air conditioning, especially in certain circumstances, long-term care facilities, etc. And heat pumps is an excellent way to get rid of the carbon. This here on the top left is a atmospheric boiler. And this atmospheric boiler, you can see if you put your hand on here, you would just get your hand burnt because that's how much heat is simply going up the flue at all times. And what we want to install are these energy efficient condensing forced draft boilers. The first time I went into a boiler room where we'd installed one of these, I put my hand on it. Oh, sorry. It still had the plastic wrap on this, you know, the stuff you get on your iPad when you buy a new one. And I turned around to the contractor and I said, I thought you said these in operation. And he says, they are. I said, well, why didn't the plastic melt? And he said, touch it. And it was just as cool. The heat just does not come out of there. That heat loss is just diminished. So we've got variable speed drives, which we love. It reduces the energy used. It works on the cube of the speed. So if you reduce the speed to 80%, you save 50% of the energy. So huge savings. Building controls, and we'll talk about this in a little while. That we need to have a building system that controls the heating, the makeup air, the boilers, the pumps, the motors, using demand control ventilation, so that in periods of low occupancy, the ventilation can be reduced. Lighting, of course, everybody is doing LEDs. And you think, well, I've done my LEDs now, move on. Well, now we've got new LEDs with which are smart LEDs, which allow for occupancy sensing, dimming. You can install the LED and install it at 80%, not even at full brightness, just to get started with. So they're quite practical. Solar walls, energy efficiency toilets, and of course battery storage, which is great for so this is a system that we installed at Wood Green, where we can pick up on a dashboard all of the critical building equipment. We can find out what temperature is in the building. We can see if there are any alerts or problems. Even the outdoor temperature is shown. And it takes us right down into the suite. You can see within each of the suites, what the temperature is, heating or cooling, and this can be limited, and problems can be addressed. So this is an output from a typical energy efficient report, and you can see that this is a conventional measures. This is looking at high efficiency domestic hot water boilers and variable speed drives, lighting, booster pumps, building automation system, toilets, etc. And you can see some of these measures have fairly long paybacks. The lighting, because this is in suite rather than common areas. And we put in a high efficiency chiller, 33 years. But overall, and this I must stress, is that if you look at this holistically, we come down with a 5.3 year payback very easily, financed under an energy efficiency program where the building owner would actually have to pay nothing up front, and this could all be paid out of savings. And the key is that we haven't taken off portions of this and done the boilers here and a little bit of the makeup there, and it's a comprehensive retrofit. And decent greenhouse gas savings, almost achieving what we need for some of the funding programs. Then we go into the convention and deep measures. And as Ian McVeigh said, this is where we have to, these are the areas that we have to start concentrating on. We're going to meet Canada's net zero goals, and that applies to cities and Ontario. Then we have to look at these things. And it's not just individual, it's not just here and there, it's every building. You have to remember that it's not other people's buildings, it's your building, and everybody is responsible. So we have to look, and this is this audit, we have a greenhouse gas reduction of 64%, which is really great. We have a terrible payback of 27 years, but we have now put in heat pumps into every single one of the units, $1.5 million being spent there, which is the bulk of the funding. And we've got some other long paybacks, putting solar voltaics. We're putting in solar duct to preheat the makeup air. So we have some long energy efficiency measures in here, but we have great long-term energy savings and reduction. So back to our energy baselines. Showed you the energy baseline in one of the earlier slides, and here you can see actual savings under energy. You can see energy baseline staying below that. All the areas where between the black line and this yellow, for example, that is all your savings. Water consumption, you can see in this building, is absolutely amazing. 30 or 40% energy water savings, and then natural gas. And again, you can see wintertime, it's when we're getting our savings. In the summertime, the natural gas is only being used. So the real-time metering that we put on was a real eye-opener when we first started with this. This one up here on the left was a booster pump in one of the first buildings that we retrofitted. And you can see that the energy is moving along very close, very nicely at 50 kilowatt hours per day. And we did the retrofit, and it dropped like a stone by 60%, and then continued very nicely. So it shows you the power of being able to do that. Is that this pump is just humming along, and whether it was needed or not, was just continuing. And now we're matching the power to the flow, and over the period of the day, it's just building. And the same with the toilets. This is what the consumption was on average pre pre-installation. So installation period, and it dropped, and we had 30% and just. So just back to the first slide that we talked about, just to wrap things around, is, where's energy being used? Well, we develop our energy baselines, develop how much we're using, and our end use inventory. We compare buildings by using the benchmark. We go through and we come up with energy efficiency reductions. We address repair costs using new equipment and indoor air quality with better ventilation and heating and cooling. And Matt had a really good slide on the impact on resident. And then the financial considerations, of course, applying for incentives and for financing. There are a number of programs that are available. I'm not going to go into detail. Matt will be covering these tomorrow. But, FCM has the Social Housing Initiative, CMHC has the Preservation Fund, and for commercial and public buildings, there's the CIB funding, and then the Green and Inclusive Building Community Fund, amongst others, right? There's also incentives from Save on Energy through IESO and from Enbridge. So how do we do this? So the key is, what are we going to be doing? We need our roadmap. We need to know what are we going to be doing, how these things are going to work, what is the interaction. Ian Sinclair mentioned about the interaction. If you do your building envelope, then your heating load is reduced. In one of the earlier slides, if you do solar preheat of the makeup air, well, then you can use a smaller heating section in makeup air. And so we have to be able to address these intricacies, and to be able to also lend the payback so that we get something reasonable that we can work with. And 50 and 70-year paybacks or 3-year paybacks, and bring it down to something reasonable to allow us to do the things. So funding and incentives. We then go into engineering, specifications and detailed drawings, make sure that everything works for the building, tendering, and then the implementation. And Marcia is going to be speaking about the implementation phase in the next session. So again, to make sure that we achieve these savings, the key elements are, number one is measurement and verification. So we're measuring on an ongoing basis, reporting quarterly, reporting annually, and we know what's going on. We have maintenance. We have an established maintenance program. The reports are done. The chemical testing is done for the water and on an ongoing basis. And then the tenant or resident education and communication, and putting a system in place, and making sure that the operators are properly trained, they understand how to use the new equipment, the occupants know what they can do, what they can actually do to reduce the impact, energy impact on the building, and then provide the ongoing communications. So at this point, thank you very much. And
thank you, Derrick. I have one question from the audience that we can address. There was a question about whether architectural components are looked at for energy efficiency upgrades in addition to mechanical and electrical.
Very definitely. So the architectural elements that we look at are, of course, the building envelope. And so we look at the building envelope, looking at what are the existing windows, the doors. We'd look at primarily on the doors, we'd look at the doors into the building to make sure that they're properly sealed and weather stripped, to avoid stack effect. On the windows, we look to see if they're properly sealed around whether they need to be corked, or if the buildings need to be replaced, or the sliders need to be replaced. We recently did an EFIS project, that's the exterior insulation foam, for 2 buildings of Victoria Park housing in Hamilton, where they had very poor insulation in the existing walls, and we were able to put in the EFIS and resolve the problems. And then what other architecture? Not sure if there's anything